Hello, this is Mr. Stansbury. I'm going to take you through some of the problems from the 7B assignment. Okay, first one. Number one, state which two variables are directly proportional and determine the proportionality constant k. So our two variables are a and r squared. So we're going to say that a varies directly with r squared, and our proportionality constant k in this case is going to equal pi. It's going to be the leftover piece right here. Okay? All right. Number two, suppose y varies directly with x cubed. Describes what happens to y if x is doubled. Okay? So, really we have y varies directly as x cubed. What's going to happen to the y if we double the x? So basically if we put a 2 in here, right? Actually, not even putting a 2 in there. We're doubling the x, right? Right? So basically, I like to think of it as this. So really what's going to happen, it's going to be 2x cubed. So if we double this x, we're actually going to do this. It's going to turn into, we distribute this 3 to both of these powers here. So that's 2 to the third, x to the third. So there's still our x cubed, but then look, by doubling x, the y is actually going to go up, going to get multiplied by 8. Okay, so what happens to y if x is doubled? So this is a. Y is multiplied by 8. Okay, and that 8 is whatever that's, like if x is doubled, it's 2 to the third power gives us 8, right? So if x was tripled, we would go 3 to the third power. Okay, if it was multiplied by 10, we would go 10 to the third power, and it goes up starts going up really fast like that. Okay, what happens to y? This is C here. What happens to y if x is increased by 20%? Okay, so now we have y varies directly as x cubed. So now this is going to increase by 20%. So that's going to be 1.2 of the x cubed. Oops, sorry, not of the x cubed. So our x is going to be, instead of just plain old x, it's going to be 1.2 of x cubed. So then really what we can do to see what happens to y is we're going to put this 1.2 in here, and we're going to raise it to the, to the third power. 1.2 to the third power gives us 1.728. So that means it increases. This is 172.8% of what it was originally. So the y is going to increase by 72.8%. Okay? Okay. 3, suppose m is directly proportional to t squared. So I always like to write our proportionality statement, make my life easy. So m is directly proportional to t squared, okay, where t is going to be greater than 0. When t equals 6, m equals 40. So let's do this. I always like to put this as my x, so that's going to be t, and that's going to be m. So it says when t equals 6, m equals 40. Find m when t equals 9. So again, we can set this up as our proportion. 6 over 40 is equal to 9 over m. But before we do any cross multiplying, our t has to be squared. So this is going to be 6 squared and 9 squared. And now we cross multiply. So 6 squared times m is 36m equals whatever 40 times 9 squared is. 40 times 9 squared gives us 3240. So then we divide both sides by 36, and we get that m should equal, divide that by 36, and we get 90. So m should be 90 when t is 9. Okay? For b, so this was A. For B, find t when m equals 120. So again, we still have the same setup. T, m, when t is 6, m is 40. That's from the original problem right here. Now we want to figure out what t equals when m equals 120. Okay, so we got 6 over 40 equals t over 120. But again, here's our direct variation statement here. So we know that the t's up here have to get squared before we do our cross multiply. Okay, so we get 40t squared is going to equal whatever 6 squared times 120 is. 6 squared times 120 gives us 4320. Divide both sides by 40, and we get that the t squared, divide by 40, we get that t squared is 108, but we don't want to know what t squared is, we want to know what t is. So then our last step on this is to square root both sides. So we square root our answer. Oops, that's not what, I don't think that was supposed to be right. Let's see, second square root of second answer. There we go, 108. 10.4 if we round it off. So time is going to be about 10.4. Okay? Okay. Taking a look here at number 6. The amount of medicine in this glass is directly proportional to the cube of its depth d. So our proportionality statement is the amount of medicine. So I'm going to do amount is going to be volume is going to equal, sorry, it's directly proportional to the cube of its depth. So directly proportional to d cubed. So that doesn't mean the volume equals whatever the depth is cubed. It's just directly proportional to the depth cubed. There's going to be some kind of constant in here, okay, that we have to multiply that by to end up with our final answer, okay? So it says the glass is 6 centimeters high and has a capacity of 40 milliliters. Okay, so if we set that up, let's do our volume, and then it's going to be our depth up here, right? So it says if, let's see, the glass is 6 centimeters high, has a capacity of 40 milliliters. Okay, find the amount of medicine needed to fill the glass to a depth of 4 centimeters. So the depth is 4. What is our volume going to need to be for that? Okay, so we would do 66 over 40 equals 4 over v. But again, our variation constant here, not our variation constant, that's k. We don't even know what that is yet. But our variation statement says that this d here has to be cubed, so we have to take the d, which is the top here, and we got to cube both of those, and then now do cross multiply. Okay, so let's see here, 6 cubed, 6 to the third, gives us 216. 216v is going to equal 4 cubed, 4 to the third. I got to go over here, otherwise it'll put the rest of that up in the power, and it's going to be an enormous number. 4 cubed times 40 gives us 2560. Okay, and then we take 216, divide both sides by 216 to figure out what our volume is going to be here. Okay, so we're going to take our 2560 here, divide it by 216, and we get 11.85. Oops, 11.85 is going to be our volume here for part A. Okay, then for part B, Jimmy needs 30 milliliter of medicine. Okay, so now we're going to I'm just going to rewrite what we had over here, d over v. Let's see, we got 6 is to 40, and now it says Jimmy needs 30 milliliters of medicine, that's our volume. To what depth should the glass be filled? So then that's d here. So we set it up, 6 over 40 equals d over 30. We check our variation, our direct variation statement here. The d has to be cubed, so it's going to be 6 cubed, d cubed, and now we can cross multiply, and away we go. Okay, so that's 40d cubed is going to equal 6 to the third times 30. And that gives us 6480. Okay. So we're going to divide both sides by 40 and get that d cubed. That's going to equal, so we divide that by 40. And that gives us 162, but that's what d cubed is, so now we have to actually cube root both sides. So then we will get that d equals. So now we're going to cube root. So this is where you'd want to do, on this graphing calculator, do math. You can actually go to 4, or you can put 3 first and then hit the x root, but since it actually has a cube root function in here, so we'll do the cube root of our answer. Second, why does it do that? I keep messing that up. Math. Go down to cube root. Second, not entry, but second answer. There we go. Keep pushing the wrong stuff. That's why that keeps happening. 5.45. 5.45 centimeters. Right, and that's 11.85 milliliters over here. Okay. All right. Number 8, kinetic energy of an object with mass m and speed v is given by E equals 1/2 mv squared. For objects traveling at a particular speed, what proportionality exists between E and m? We look at the E and the m, it's just going to be E varies directly with m, right? Because there's no power with the m. Okay. For B, for an object with constant mass, that's the m, what proportionality exists between E and V? So that would be, for part B, we have E varies directly with V squared, right? Okay, that's all we have for this here. So if you have any further questions on this assignment, please feel free to ask. Thanks.